Hello everyone. Hey, welcome to Ask IITians. So this is lecture number 3 and the last lecture of linear equations in two variables. Right. I am Manish Nihalani, your mathematics mentor. I have guided thousands of students for IIT-JEE preparations, and a couple of them have produced some good results and now currently are studying their graduations in IITs and NITs as well, and various other reputed institutes. So regarding the linear equations in two variables, we have already covered two classes wherein we talked about how are these equations being discussed, and how is it to talk about the linear equations in a graphical manner, and what is their solution represents, and how can we write a line parallel to x-axis, parallel to y-axis, and what is the points of contact. So now today we would be covering these topics, which are graphical solutions of two simultaneous equations, linear inequations of two variables, and graphical solution and slope. Right. So let's see what is graphical equations of two simultaneous equations. In the last class, we had talked about graphical equation or graphical representation of one linear equation. Now we have two simultaneous equations. That is, we have, let's say, x plus y, is equal to 2, and then we also have 4x minus y is equal to 3. Right. So if we have to find the solution of these equations, we would say let's solve them. So if we add both these equations, if we add, what do we get? We get x plus 4x 5x plus y minus y gets cancelled, and this is equal to 5. So from here, 2 plus 3 is 5. So from here we get x is equal to 1. So substituting x is equal to 1 in maybe equation 1, what do we get? So substituting x is equal to 1 in equation 1, we can clearly see that we will get y is equal to 2 minus 1, which is just 1. So y is equal to 1, x is equal to 1 is the solution of these two simultaneous equations. Right. Now what do we mean by this? What do we mean by this graphically? So if you'll remember, in the last class we had talked about that one equation represents one line. Right. One equation represents one line. Right. And when we talk about the linear equations in two variables, you can plot them on a graph paper. So you would say the first equation can have x by 2 as the x-intercept and 2 as the y-intercept, right? Because when you put x equal to 0 and y equal to 0, you get a straight line which is like this, right? So this is your linear equation in two variables, right? This is linear equation in two variables, which is x plus y is equal to 2. This point is 2 comma 0. This point is 2 comma 0, and this point is 0 comma 2. Now when you try to plot the other equation as well, that is 4x minus y is equal to 3, you would be able to see that when your y is 0, x is 4 by 3. Now 4 by 3 is 1.33, which is less than 2. So in that case, this is your 4 by 3 when your x is 0. Similarly, when your y is 0, when your y is 0, sorry, when your x is 0, your y value is minus 3. Your y value is minus 3. So which means when your x is 0, y is minus 3. When your y is 0, x is 3 by 4. 3 by 4 is 0.75, which is like this. Now when you try to connect these two lines, and when you try to connect these 2 points, you get a straight line, right? You get a straight line which is parallel to itself, and when it meets the previous line, you say this meeting point is actually the solution of the given two equations, that is x is equal to 1 and 1 y is equal to 1. So 1 comma 1 is the solution. This is what we mean graphically. 1 comma 1 is the solution of this simultaneous equations. This is what we have using graphical method. So next question is, we have using graphical method you have to find the solution of system of equations, right? So you have y plus x equal to 3. Similarly, you can basically try solving these two, and you would be able to get the point of intersection here as 1 comma 2. So how will you solve these two equations? You can say first arrange them. So you would say x plus y is equal to 3, and the second one is 4x minus y is equal to 2. 4x minus y is equal to 2. When you add these two equations, you get 5x is equal to 5, which means your x is just 1. When you put x equal to 1 in the equation 1, you would get y is equal to 3 minus 1, which is just 2, which implies y is equal to 2 is the other solution for this equation, right? Y is equal to 2 is the other solution of this equation. So when you say x equal to 1, y equal to 2, it means these are the two lines, and this is the solution of these two lines, right? So this is how linear equations in two variables are solved, and they are plotted graphically to get the solution, right? Now this is what we will be talking about, some inequalities now, linear inequations, because you would see now your x power 1 and y power 1, but here instead of equal to sign you have an inequality sign. So the solution of a linear inequality in two variables is like ax plus by greater than c in ordered pair x comma y produces true statement when you substitute x comma y, which means when you have the graph of the linear inequality in two variables is a set of points that represents all solutions to the inequality, right? A linear inequality divides the coordinate plane into two halves by a boundary line. The one half represents the solution, so the one which represents the solution is usually shaded. So you all can see that this shaded region to the right of the red line represents your solution set. These all are your solutions of the equation, and this red line is exactly representing your ax plus by is equal to c line. This is your x plus by equal to c. Now it says ax plus by greater than c, so it means you have to move away from the origin in that case. If it would have said less than c, because you can clearly see that it will tell you ax plus by minus c greater than 0. So if the answers have to be positive, which means you have to move away from the origin. In that case, this is the shaded region. So you can see that this shaded region represents all the solutions, which means that a linear inequation will not necessarily have one point of intersection, because you are saying it's inequalities greater than this, which means greater than this. For example, if I ask you, tell me the numbers greater than 5, so you would say, so there will not be any finite numbers, there can be infinite numbers greater than 5, right? So in that case you would get many solutions, you just not get a couple of solutions in that case. It also depends on number of lines which you are considering. So for one line you can have infinite solutions, right? Next, so it says now solve the y is less than equal to 2. So now first of all you need to plot y equal to 2 on a line. So now what we have learned in the last class, that whenever we are considering y is equal to k, y is equal to k or y is equal to 2 in this case is a line which will always be parallel to x axis. Absolutely correct, it will be parallel to x axis. Now if this y equal to 2, it says plus 2, so when it's plus 2 it has to be to the above x-axis, right? It has to be above x-axis, whereas if it had been minus 2, it has to be below x-axis. So y equal to 2 is a line which is parallel to x-axis 2 units above it, 2 units above it, right? And where will it meet the y-axis? At a point 0 comma 2. Absolutely correct. Now it says you have to solve for y less than equal to 2. So when it says less than, you can clearly shade the region which is towards origin. So this is your origin. So towards origin means this region. So all the solutions which are below this line, because you all can see that this line can be extended in infinite directions, right? Right. So all these solutions which are below this line will be coming under this equation y less than equal to 2, right? So you all can also shade it like this. This is the shaded region. It has to be below that line, right? So this is your y equal to 2 line. You need y less than 2, so that is a below. So as you all can see here, right, excluding the points on the line. If it would have said that y less than equal to 2, then in that case you would have also considered the points which are on that line. But here he's saying y less than 2, which means you will not consider the points on that line, right? Correct. Now let's try to understand this very important concept, because we have been talking about slope. Whenever you will talk about a line in 2 dimensions, see, line can also be in 3 dimensions. Now you will ask me, sir, how can a line be in 3 dimensions? So it means if its line is your transverse direction, that is, it's coming from x-axis, it's perpendicular to y-axis and traveling through z-axis. So in that case your line would be a 3 dimensional line, right? So okay, we will be restricting ourselves to 2 dimensions, but whenever you are talking about a 2D line, you would always talk about a concept called as a slope. So this slope is the basically the, you can say, identity of the line. पहचान है ये लाइन की पहचान क्या है, उसके स्लोप से होती है. Now what is slope? So you all know that when you talk about a staircase, the staircase is also has a slope, right? Because it is used to either climb up or travel down. So a staircase also has a slope. So we know like a sloping surface is nothing but inclination. So the slope is the steepness or the inclination or the incline of a line, right? So the x and y coordinates are used to calculate the slope. So for example, here in this figure, if you have a line L, ठीक है, हमारे पास ये लाइन एल है, इसका इक्वेशन कुछ भी हो सकता है. क्या हो सकता है इसका इक्वेशन? इट कैन हैव ए एक्स प्लस बी वाई इज इक्वल टू सी. ठीक है. What we are doing, we are just considering 2 random points. So we considered a point P on this line which has coordinates x1 comma y1, and we considered a point Q on this line which has coordinates x2 comma y2. Correct. So we would say slope is defined as change in y-axis, ratio of change in y-axis to the change in x-axis. So if you see that change in y-axis, so what we did after considering those 2 points, we dropped perpendiculars from both those points to the x-axis and y-axis respectively. This is your y-axis, this is your x-axis. So we dropped the perpendicular and we said let them meet at M, and let this M has coordinates x comma y. So if we have to find distance qm, you would say vertical distance of vertical y coordinate of q minus y coordinate of p, because that will give you qm. So that is nothing but y2 minus y1, and horizontal distance would be x2 minus x1. So slope is always given as y2 minus y1 upon x2 minus x1. Now someone could say, sir, what if I am considering the coordinates of p as x2 y2 and coordinates of q as x1 y1? So in that case also the formula will not change. It will remain same because you are taking the ratio. So your minus minus will get cancelled. You would basically get the same answer, because we are just interested in finding the steepness of the line, right? How much steep or how much flat the line is. So that is why this slope formula is used. Y2 minus y1, that is vertical distance between 2 points. You would say vertical distance between 2 points upon horizontal distance between 2 points. Right, vertical distance between 2 points upon horizontal distance between 2 points, right? So this is about slope, right? Now you have to find the slope of the line whose coordinates are this. So you would say let x1 comma y1 be, acha, in this case let's do the ulta because some of you still might have doubt. So let's say x1 comma y1 a comma 1, x2 comma y2 is 2 comma 7. ठीक है. So therefore slope का formula is m, it is denoted by m, it is equal to y2 minus y1 by x2 minus x1. So y2 minus y1 would be 7 minus 1, x2 minus x1 would be 2 minus 8. So this would be 6 by minus 6, which is just minus 1. So slope of this is basically there is a line which has these 2 points on it. ठीक है, its slope is minus 1. ठीक है, slope is minus 1. Correct. So you all can see that this is a slope minus 1, right? And you all can see that as m is changing here, as the m value is changing, the line is changing, it's getting inclined, right? So this is what we need to understand, that as slope is a very important parameter from lines perspective. It defines the identity of the line, and that is why we have seen the formula of the slope, that is y2 minus y1 upon x2 minus x1, that is vertical distance between 2 points upon horizontal distance between 2 points. Correct. So I hope you all understood the concept of slope, how to represent equations graphically and find their solutions as well. So these are some practice questions for you all, which you all can try as a homework. So the first question is like a application based question, which we discussed in the first lecture as well. That you'll remember in the first lecture we discussed the boat problems where the boat was flowing downstream, boat was flowing upstream. So this is like that. So this is exactly similar to that sum. And in the second, you have to just find the value. You have given the value of slope, you just have to find the value of b. So you would say slope ka value is 3, so you would say y2 minus y1 upon x2 minus x1 is just 3. Find b. Very simple. The third one is also, you just have to represent these equations geometrically or represents these equations graphically. It's the same thing. So you have to just plot these two equations on a graph, right? On the highway number 1 equation and highway number 2 equations on a graph. So once you like solve them, we would be discussing. So hopefully you all will try these questions as a part of practice sum and get the answers of this, right? So till then, stay safe, take care. I know you all are in the middle of pandemic and we are facing a crisis in the world. So till then, take care, uh, take precautions, and stay safe. Okay then. Thank you so much. See you all in next class.